Today we are going to be solving quadratic equations by using the quadratic formula. This is section 10.6. Here you have the quadratic formula. It is quite a great looking formula, and it's a formula that you'll need to have memorized. I wonder how I could memorize this formula. All those notes around there give me an idea. There could be a song for this. How about something that goes to the tune of Pop Goes the Weasel? Listen up. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Take a look at that quadratic formula. A's, b's, and c's, those are all the coefficients to the three terms in the quadratic equation. Substitute them into the formula, and you will find out the solutions to your quadratic equation. The quadratic formula can be used for any quadratic equation. You've already learned how to graph, how to factor, how to use completing the square, and also just square root equations. Now you have the ultimate, the quadratic formula. Let's sing it together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to know this formula for ACT tests, for future math classes, and to be able to do my homework. Let's solve this equation by using the quadratic formula. The first thing, we need to have the equation in standard form. So that means that we need 2x squared plus 7x minus 9 equals 0. Remember, standard form has all of our terms on one side and 0 on the other side. Then let's start substituting. X equals negative b. Now, negative b means that you're going to take the opposite of whatever b is. B is 7, so the opposite of b is a negative 7. Plus or minus the square root of b squared. Well, again, b is 7, so we're going to say b squared, that's 7 squared, minus 4ac. A is a 2, and c is a negative 9. All over 2a. So 2 times what a is, in this case a is a 2. And now you just have an expression here that we have to actually use our order of operations on. Start with what's underneath the square root sign. So we have negative 7 plus or minus the square root, 7 squared being 49. Then you have negative 4 times 2 times a negative 9. A negative times a negative is a positive. 4 times 2 is 8. 8 times 9 is 72. And over the 4. 2 times 2 being 4. Add up your 49 and your 72, and that gives us a sum underneath the radical of 121 all over 4. We all know the square root of 121. That is equal to 11. And now you need to finish simplifying your answer so that you have x equals a negative 7 minus 11 over 4, and x equals a negative 7 plus 11 over 4. Negative 7 minus 11 is a negative 18 over 4, which when we reduce that becomes a negative 9 over 2. The other one has negative 7 plus 11, which gives us a positive 4 over 4. And when we simplify that, we get a positive 1. So we have a negative 9/2 and a positive 1 as our two answers. If you want to make that a negative 4.5 and a positive 1, that's fine as well. Let's use the quadratic formula again. This time x is on the right-hand side. Be careful that when you bring that over, you put the equation so that it is from highest degree to lowest degree. And then let's start substituting our a, b, and c into the quadratic formula. X equals negative b. Well, this time b is a negative 1, so the opposite of a negative 1 is a positive 1. Plus or minus the square root of b squared. So we'll have a negative 1 squared minus 4ac. Negative 4 times 3 times a negative 1 all over 2a. And our 3 is our a this time. Again, start simplifying what's underneath the radical. So we'll have 1 plus or minus. And if you could have done that negative 1 squared and known it was a positive 1 right away, awesome. Then we'll have minus, actually plus, because we have a negative times a negative, so it's a plus 12 all over 6. Simplifying underneath the radical gives us 1 plus or minus the square root of 13 over 6. Now, this is an exact answer with radicals. If I am asking you on a test for an exact answer with radicals, this is the answer that I want. If I am asking you for approximations as an answer, then I want you to do the following. We'll have x equals 1 plus the square root of 13, all divided by 6, and x equals 1 minus the square root of 13, all divided by 6. And we have to find out what the square root of 13 is, and let's round that off to the nearest hundredth, please. So 1 plus 3.61 divided by 6, and we will have x equal to 1 minus 3.61, all divided by 6. When we add these together on the first one, we will have 4.61 divided by 6. So you pick up your calculator, and when you do that division, you will end up with x being equal to 0.77 to the nearest hundredth, please. 1 minus 3.61 is equal to a negative 2.61 all over 6. And that means when we divide by 6, we will find out that x is a negative 0.44. We now have two decimal approximations for our answer, as opposed to two answers that are exact with a radical. Please read the directions as to which one is asked for in your question. What if underneath the radical there is a 0? Well, think about this for a moment. You know that the square root of 0 is equal to 0. So we really are left with x equals negative b all over 2a, which is our formula for the x-coordinate of the vertex. It's our axis of symmetry when we are graphing a parabola. And so this means that there is only one solution to our problem. That is when that vertex is sitting right on the x-axis. So there's only one solution to our problem when 0 is underneath the square root sign. What if underneath the square root sign it is a negative? We know that in Algebra 1 we are working with only real number solutions, and so we cannot take the square root of a negative number at this time. Later in your math courses, we know about imaginary numbers. We will do it later. But right now, we are only considering real number solutions. So, since I cannot take the square root of a negative number, I am going to write no solution as the answer to this problem. We all know that would be no real solution. For our problems, if you get a negative underneath the radical, you may stop and write no solution. Good luck. Thank you.